Welcome, everyone. I'm Ralph Clayton, host of the VTM Podcast. This is episode 22. Today, I want to take you into one of the most elegant and patient journeys, now unfolding in deep space. Europa Clipper's return past Earth. Due ice on its long road to Jupiter. Gravity assists. Ocean moons. Habitability. And the strange fact that two spacecraft, launched by different agencies, are now using the inner solar system as a celestial engine on their way to some of the most promising worlds we know. This is not simply a story about Jupiter. It is not simply a story about spacecraft trajectories. And it is not only a story about icy moons orbiting far from the sun. At its deepest level, this episode asks one dangerous question. What if the best places to search for life are not worlds like Earth on the outside, but worlds hiding oceans beneath ice? Because when most people imagine life beyond Earth, they imagine a planet, a blue world, a rocky surface, a sky, clouds, rain, maybe continents, maybe a star shining at the right distance. The old dream is an Earth twin, a planet where seas glitter under sunlight, a planet where air moves across land, a planet where life announces itself openly at the surface. But the solar system has taught us to be less simple. It has taught us that habitability may wear disguises. A world can be frozen on the outside and alive with possibility beneath. A moon can orbit far, beyond the traditional warmth of the sun, and still hold an ocean. A crust of ice can conceal liquid water. Gravity can become a furnace. Tides can knead a world from within. Chemistry can gather in darkness. And life, if it exists there, may not know sunrise at all. That is why Europa matters. And that is why Ganymede and Callista matter. They are not Earth. They are not even planets. They are moons of a giant planet. They live in the domain of Jupiter, a world so large that it bends the architecture of everything around it. Jupiter is not only a planet, it is a system, a miniature empire of gravity, radiation, magnetism, storms, rings, and moons. And among its moons, the icy worlds are some of the most scientifically important places in the solar system. Europa is perhaps the most famous. Its surface is bright, fractured, young-looking, and crossed with reddish, brown bands and chaos terrain. It looks wounded. It looks restless. It looks like a shell under stress. Beneath that shell, scientists have strong evidence for a global ocean. A dark sea wrapped around the moon beneath ice. This is why Europa is one of the most exciting targets in planetary science. Not because we know life is there. We do not. Not because Europa is comfortable. It is not. Europa is cold. It is bathed in Jupiter's radiation. It is distant from the sun. Its ocean, if accessible at all, is hidden beneath an ice shell whose thickness remains a central scientific question. But Europa has three ingredients that make scientists pay attention: liquid water, chemistry, energy, the basic habitability triangle. Water alone is not enough. A sterile ocean is possible. Chemistry alone is not enough. A dead laboratory is possible. Energy alone is not enough. A violent environment can still be lifeless. But together, these ingredients make Europa compelling. And the mission of Europa Clipper is to investigate whether Europa has the conditions that could support life. That distinction matters. Europa Clipper is not primarily a life detection mission. It is a habitability mission. It will not land. It will not drill through ice. It will not swim in the ocean. It will not scoop up alien organisms. Its work is subtler, harder, more disciplined. It will fly past Europa again and again, studying the moon from orbit around Jupiter. It will investigate the ice shell. It will study the surface composition. It will examine the moon's geology. It will measure the magnetic and plasma environment. It will search for clues about the ocean. It will look for places where the surface and subsurface may exchange material. It will ask whether Europa is a world where life could exist. That is a different kind of question from, is there life? But it is the question that must come first. Before life can be claimed, habitability must be understood. Before biology can be suspected, environment must be measured. Before imagination can leap, instruments must listen. That is the discipline of planetary science. Wonder, but with instruments. Hope, but with error bars. Ambition, but with trajectory corrections. Europa Clipper began its journey in October 2024. It did not launch straight to Jupiter. A direct path would have required too much energy. Instead, the spacecraft is using gravity assists. This is one of the most beautiful ideas in spaceflight. A spacecraft can steal a little motion from a planet, not in the crude sense of colliding with it, but by falling into the planet's moving gravitational field, curving around it and leaving with its path changed. The planet barely notices. The spacecraft is transformed. A gravity assist is a conversation with momentum. The spacecraft enters. The planet pulls. The trajectory bends. Speed changes. Direction changes. A mission that could not be done with the launch energy alone becomes possible. This is not magic. It is orbital mechanics. But orbital mechanics often feels like a form of poetry written in mathematics. Europa Clipper first used Mars. In March 2025, it swept past the red planet for a gravity assist, bending its path and gaining what it needed for the next leg. Then, in December 2026, it will return to Earth. That is the strange and beautiful part. A spacecraft launched from Earth will come home briefly, not to stop. but to be flung onward. It will swing past our planet at a few thousand kilometers above the surface. It will use Earth's gravity to shape the final major leg toward Jupiter. It will be close enough, in cosmic terms, to remind us that interplanetary missions are not simply departures. They are negotiations with Mars, with Earth, with the Sun, with time, with fuel, with geometry, and with the patience required to reach the outer solar system. During that Earth flyby, Europa Clipper will not be doing the science it was built to do at Europa. But flybys are never meaningless. They are opportunities. Instruments can be checked. Calibrations can be refined. Systems can be tested. The spacecraft can use Earth as a known world, a target whose magnetic field, thermal behavior, and environment are already deeply studied. A spacecraft on its way to an alien moon can practice with home. That image matters, because Earth is not only the launch point, it is the reference world. It is the only world where we know life exists. It is the benchmark against which every search for habitability must be measured. Europa Clipper's Earth flyby in December 2026 is therefore more than a maneuver. It is a moment of return before exile, a last encounter with the world that made the mission possible. Then, if all goes as planned, Europa Clipper continues outward, toward Jupiter, toward the cold, toward the radiation belts, toward a moon whose ocean may be one of the best places in the solar system to ask whether biology can begin away from sunlight. But Europa Clipper is not alone in the larger story. Europe has its own spacecraft on the way. JUICE, the Jupiter Icy Moons Explorer, an ESA mission launched in April 2023. Where Europa Clipper is intensely focused on Europa, JICE has a broader Jovian vision. It will study Jupiter and three of its large ocean-bearing moons: Ganymede, Callisto, Europa. But its deepest destination is Ganymede. That matters. Ganymede is the largest moon in the solar system, larger than Mercury, a world with its own magnetic field, a world believed to contain a deep internal ocean, a world layered with ice, rock, and hidden water, a moon so large and complex that JUICE will eventually enter orbit around it. If successful, that will make JUICE the first spacecraft to orbit a moon of another planet. That sentence should not pass too quickly. For all the triumphs of spaceflight, we have never placed a spacecraft in orbit around a moon beyond Earth's moon. JUICE aims to do that at Ganymede, not simply to fly by, not merely to glance, but to stay, to map, to measure, to understand a planetary body in its own right. This is one of the great conceptual shifts in modern planetary science. Moons are no longer minor objects. They are worlds. Europa is a world. Ganymede is a world. Callisto is a world. Titan is a world. Enceladus is a world. They are not leftovers. They are not decorative companions to planets. They are archives. They are laboratories. They are possible habitats. They are places where geology, chemistry, ice, water, radiation, tides, and time have written histories different from anything on Earth. GIC's road to Jupiter is even more intricate than Europa Clippers. It launched from Earth, but not with enough energy to go straight to Jupiter. So it uses a long slingshot path through the inner solar system. In August 2024, GIC performed a world, first lunar, Earth gravity assist. First the Moon, then Earth. A double maneuver. A celestial threading of the needle. It did not simply use Earth alone. It used the Earth, Moon system. That was not just a spectacle. It was navigation of extraordinary precision. The flyby changed GIC's path, setting it up for a later Venus flyby. Then the road continues, a Venus flyby, an Earth flyby in 2026, another Earth flyby in 2029, and then, finally, Jupiter arrival in 2031. This is the long road, not a straight road, a curved road, a road that loops inward before reaching outward, a road that seems, to the impatient mind, almost backwards. Why go toward Venus if the destination is Jupiter? Why return to Earth? Why spend years moving through the inner solar system when the prize is in the outer dark? Because spacecraft are limited. Rockets are limited. Fuel is limited. Mass is limited. And gravity is free if you know how to use it. That is one of the great lessons of interplanetary exploration. The solar system is not empty space. It is a machine of motion. Planets are not obstacles. They are engines. Moons are not merely targets. They are turning points. A mission designer does not simply draw a line from Earth to Jupiter. A mission designer composes a path through moving worlds. Everything moves. Earth moves. Mars moves. Venus moves. Jupiter moves. The spacecraft moves. The target is not where it is. The target is where it will be. And the spacecraft must arrive not only at the right place, but at the right speed, in the right direction, with enough fuel left to do science. That is why gravity assists feel almost mythic. They are acts of timing. The spacecraft must arrive when the planet is there. A few minutes matter. A few kilometers matter. A tiny error can grow into a great miss. The journey to Jupiter is therefore not only about distance. It is about precision across years. This is what both Europa Clipper and GICE teach us. Deep, space missions are not explosions of ambition. They are long disciplines. They are designed decades before their best science returns. They are launched years before arrival. They endure sunlight, darkness, radiation, thermal changes, communication delays, software anomalies, trajectory corrections, and the ordinary fragility of machinery traveling through emptiness. They must survive before they can discover. That is another quiet truth. A spacecraft earns its science by staying alive. The instruments may be brilliant. The questions may be profound. The target may be one of the most exciting places in the solar system. But first the spacecraft must function. Power must flow. Solar arrays must generate electricity far from the sun. Antennas must point. Computers must remain stable. Thermal systems must protect components from heat and cold. Propulsion must work. Reaction wheels must manage orientation. Fault protection must keep small problems from becoming fatal. Ground teams must notice, diagnose, and correct. A mission is not only the spacecraft. It is the spacecraft and the people who keep it alive. Europa Clipper and GICE are both enormous acts of trust between machine and human attention. They carry instruments into places where no engineer can reach them by hand. They must be repairable only by command. They must survive, not because they are invulnerable, but because they are carefully designed, carefully operated, and carefully watched. And then, after all that, they reach Jupiter. Jupiter is not gentle. It is beautiful. It is immense. It is scientifically rich. But it is not gentle. The Jovian system is one of the harshest environments a spacecraft can enter. Jupiter's magnetic field is powerful. Its radiation belts are dangerous. Charged particles can damage electronics. Europa, especially, orbits deep enough in that environment to make mission design difficult. That is one reason Europa Clipper will not orbit Europa directly. Instead, it will orbit Jupiter and perform repeated close flybys of Europa. This allows the spacecraft to spend less total time in the most intense rates radiation environment, while still gathering close up data. That mission architecture is a compromise. And like many good engineering compromises, it is a form of wisdom. Do not stay where the environment will kill you quickly. Pass through. Retreat. Return. Measure again. Over many flybys, a picture builds. A moon cannot be understood in one glance. Europa Clipper will build its understanding pass by pass, flyby by flyby, line by line, spectrum by spectrum, radar track by radar track, magnetic measurement by magnetic measurement, thermal anomaly by thermal anomaly, image by image. GICE, meanwhile, will study the wider system. It will examine Jupiter's atmosphere and magnetosphere. It will observe Callisto, a heavily cratered world that may preserve ancient history. It will study Europa through flybys, and it will focus increasingly on Ganymede, where it will eventually enter orbit. Together, these missions create a new era. Europa Clipper gives depth at Europa. GICE gives breadth across the icy moons, with special depth at Ganymede. They are different missions, but scientifically, they are companions. They ask related questions from different angles. What makes an icy moon habitable? How thick is the ice? How deep is the ocean? How does the ocean interact with rock? How does radiation alter the surface? Can material from the ocean reach the surface? Does chemistry move between surface and ocean? How do tides shape the interior? How do magnetic fields reveal hidden seas? How do these moons differ from one another? Why might Europa be more active? Why might Ganymede preserve a different kind of environment? Why does Callisto seem more ancient, less altered, and yet still potentially ocean-bearing? This comparative approach is crucial. A single world can mislead. A system teaches. Europa, Ganymede, and Callisto are all icy moons. But they are not the same. They differ in size, distance from Jupiter, radiation environment, geological activity, surface age, interior structure, possible ocean depth, energy availability, history. By comparing them, scientists can ask not only whether one moon is habitable, but what conditions make icy worlds habitable at all. That question extends beyond Jupiter. It reaches Saturn, Titan. It reaches Uranus and Neptune's moons. It reaches exoplanets. It reaches the possibility that ocean worlds may be common in the galaxy. Not bright blue planets under warm suns, but hidden oceans, buried seas, moons and planets where liquid water survives beneath ice, heated by tidal flexing, radioactive decay, chemistry, or residual internal warmth. This could expand the meaning of habitability. For decades, the search for life beyond Earth often centered on the habitable zone around stars, the region where a rocky planet could, under the right conditions, have liquid water on the surface. That remains important. But ocean moons teach another lesson. A world can be far outside the classic habitable zone and still possess liquid water. It can hide its ocean from sunlight. It can be warmed from within. It can be habitable in a way that does not look like Earth at all. This does not mean such worlds are alive. It means they must be taken seriously. Habitability is not a postcard. It is a set of conditions. And those conditions may exist in darkness. This is why Europa's ice is so important. The ice is not merely a barrier. It is an archive. It may preserve materials from below. It may be altered by radiation from above. It may crack, shift, overturn, and recycle. It may contain pockets of brine. It may contain chaos regions where the surface has been disrupted. It may mark places where energy and chemistry interact. For a spacecraft, the surface is the accessible text. The ocean is hidden, so the surface must be read carefully. The reddish streaks, the fractured bands, the ridges, the thermal signatures, The chemical fingerprints, the induced magnetic signals, the possible plumes, if they exist and can be detected. Each clue is partial. Together, they may reveal whether Europa's ocean is connected to the surface, whether it has the chemistry needed for life, and whether future missions should attempt the far, harder step of landing or sampling. Europa Clipper is therefore also a pathfinder, not only for knowledge, for decisions. Where should a future lander go? What regions are most scientifically valuable? Where might fresh material from below be exposed? Where is the radiation least destructive? Where is the surface too rough? Where might habitability be most accessible? Good exploration does not only answer questions. It prepares better questions. GUICE does the same for Ganymede. Ganymede's ocean may be trapped between layers of ice. Its internal structure may be complex. Its magnetic field makes it unique among moons. Its surface preserves both ancient, dark terrain and younger grooved regions. Its interaction with Jupiter's magnetosphere is unlike Europa's. By orbiting Ganymede, GUICE can investigate that world in sustained detail, not as a brief encounter, as a planetary body worthy of its own orbital campaign. This is the deep meaning of these missions. They are not racing to a headline. They are building planetary knowledge, slowly, precisely, with enormous effort. The December 2026 Earth flyby of Europa Clipper and the 2026 Earth flyby phase of JUICE are reminders of the road before the revelation. The public often notices launches and arrivals, the fire at the beginning, the first images at the end. But between launch and arrival is the hidden life, the mission, cruise, calibration, trajectory correction, instrument checks, software updates, navigation, communication passes, thermal management, gravity assists, small anomalies, resolved problems, years of patience. That middle phase is not empty. It is where the mission survives into meaning. A spacecraft in cruise is not idle. It is becoming ready. This is especially true for missions to the outer solar system. They must operate far from Earth, with communication delays and limited power. They must endure environments that cannot be duplicated perfectly on Earth. They must arrive years later, still capable of doing the job they were built to do. That is why flybys matter. They are not only speed changes. They are rehearsals. They are checkpoints. They are proof that the spacecraft can navigate precisely through a planetary encounter. They allow instruments and teams to practice. They reveal how the machine behaves in real space, not only in test chambers. And they remind us that exploration is continuous, not only at the destination, but along the way. There is also something emotionally powerful about Earth flybys. A spacecraft leaves Earth, Then, years later, it returns. Not because it failed. Because returning is part of going farther. This is a strange lesson. Sometimes the path outward requires coming home. Europa Clipper will use Earth's gravity to continue toward Jupiter. JUICE will do the same on its longer slingshot route. In both cases, Earth becomes not only origin, but helper. The planet that built the spacecraft lends its motion to the spacecraft. Our world literally gives the mission a push. There is poetry in that. But there is also humility, because we often imagine space exploration as conquest, as if humans simply throw machines into the void by force of will. But missions like Europa Clipper and JUICE show something gentler and more exact. We do not conquer the solar system. We cooperate with its motion. We borrow gravity. We wait for alignments. We accept limits. We use the paths the planets make possible. The spacecraft is not a spear. It is a dancer. That is the beauty of gravity assists. They turn limitation into rote. They turn patience into velocity. They turn celestial motion into mission architecture. And now, that architecture is carrying two of humanity's most sophisticated ocean world explorers toward Jupiter. If these missions succeed, they will not answer every question. They will not tell us definitively whether life exists beneath Europa's ice. They will not fully map every layer of Ganymedes' ocean. They will not settle all debates about icy moon habitability. But they will transform the question. They will narrow uncertainty. They will reveal structure. They will show where the ice is thin or thick, where chemistry is rich or altered, where geology is active or ancient, where oceans may interact with rock or remain isolated. They will tell us whether the ocean worlds of Jupiter are merely interesting, or whether they are among the greatest astrobiological targets in the solar system. And if they find signs of active exchange between ocean and surface, the consequences will be enormous, because life needs access, not for itself necessarily, but for our ability to detect it. A buried ocean, sealed under tens of kilometers of ice, is scientifically tantalizing, but difficult to sample. A world where material from the ocean reaches the surface is different. That world gives the universe a way to speak outward. Chemistry from below may be carried upward. Radiation may alter it. Surface processes may preserve or destroy it. But at least there is a pathway. At least the hidden ocean is not entirely hidden. That is why cracks, ridges, chaos terrain, plumes, and surface composition matter so much. They are not just features. They are possible messages. The search for habitability often begins with geography. Where is the exchange? Where is the energy? Where is the chemistry? Where is the water? Where is the history? Where is the place where a future mission should kneel down and touch the ice? That future is still beyond Europa Clipper. But Europa Clipper may help choose it. And GICE may help us understand whether Europa is unique, or whether ocean worlds come in many forms. This is the fourth lesson. The search for life is not one mission. It is a sequence of questions. First, could there be an ocean? Then, what is the ocean like? Then, does the ocean have chemistry and energy? Then, does the ocean communicate with the surface? Then, where would evidence be preserved? Then, can we sample it? Then, can we recognize life if it is unlike life on Earth? Every mission moves the question forward. Galileo gave us evidence and mystery. Europa Clipper and GICE will give us detail and comparison. Future landers, orbiters, cryobots, or sample return concepts may one day take the next steps, but not without the knowledge these missions provide. That is how science advances, not by skipping to the final answer, by earning it. So what are Europa Clipper's Earth, Flyby, and GICE's long road to Jupiter truly about? They are about navigation. But navigation is only the surface. They are about gravity. But gravity is only the engine. They are about icy moons. But ice is only the door. They are about oceans, hidden where sunlight barely reaches. They are about habitability, beyond the old imagination. They are about patience in an age of impatience. They are about machines that must travel for years before beginning their deepest work. They are about the humility of using planets as partners. They are about Earth sending explorers away, then pulling them close once more, then letting them go. And they are about the possibility that some of the most important seas in the solar system have never seen the sky. Europa Clipper will come home in December 2026, only to leave again. GICE will pass Earth on its longer slingshot path toward Jupiter and its moons. Both spacecraft are still in the road, before the road. The journey before arrival. The quiet years before the revelations. But those quiet years matter, because no ocean world gives up its secrets quickly. A moon buried under ice must be approached with patience. A spacecraft crossing the solar system must be guided with precision. A claim about habitability must be built from evidence. And a search for life must be worthy of the question it asks. The great voyages are already underway. One spacecraft, aiming its deepest attention at Europa. Another carrying Europe's long ambition toward Ganymede, Callisto, Europa, and Jupiter itself. 2 missions, 2 routes, 1 system. One enormous question. Are the dark oceans of the outer solar system only water? Or are they places where chemistry, energy, and time have begun to move toward life? We do not know. That is why we go. I'm Ralph Clayton, host of the VTM Podcast. Thank you for joining me for episode 22 and this look into Europa. Clipper's Earth flyby, due ICE on its long road to Jupiter, and the ocean worlds waiting beneath ice. And remember, not every ocean lies beneath a blue sky. Not every journey outward moves in a straight line. And sometimes, the search for life begins when a spacecraft comes home just long enough for Earth to send it farther into the dark.